Okay, let's go ahead and get started on doing right triangles and the Pythagorean theorem. So, when you're looking at this right triangle right here, we have sides A, B, and C. So A and B, as we've talked about before, A and B are called the legs, and side C is called the hypotenuse. Okay, the way to find the hypotenuse is always look at your right angle right here, and you want to travel directly across them. Here is the hypotenuse. Alright, so it says it's used to find the missing length of a right triangle. So the Pythagorean theorem is going to help us because we have an equation in which we're going to go through and solve for x. So the equation for all side lengths of right triangles is c squared equals a squared plus b squared. Alright, so the hypotenuse squared is equal to the leg squared plus the other leg squared. So we have three examples here. So it says find the missing side length. So what we're going to do is we're going to label. So first we're going to find the hypotenuse. So I'm going to go, here's my right angle, directly across, that's our C. Now the other two things are absolutely interchangeable. So A and B, it doesn't matter which one you choose to be which. So we'll call this one A and this one B. So our formula goes C squared equals a squared plus b squared, which means we have x squared equals 8 squared plus 13 squared. Now, you should know some of your perfect squares, although we don't expect you to know them all. You can always use a calculator if you need to, but it is good to have that in your working memory. So, x squared equals 8 squared is 64 plus, and then if you need a calculator for 13 squared, that's fine. It's 169. All right, now we're going to go through and add those two things. So x squared equals, all right, so 64 plus 169 is 234. All right, I'm going to double check my math there. All right, in checking, I realized it was 233. So what we're going to do now is we need to remember how to solve an equation. So this is back in Algebra 1. I have x squared. If I have an exponent of 2, how do you undo squaring something? Correct. You're going to square root it. So we're going to put a square root in front of this one and a square root in front of this one. On the left side, this squared and this square root cancel each other out. So I'm left with just x. And then I have the square root of 233. Now I need to double check and make sure that I'm simplifying the radical, so I'm going to go 233. I'm going to try and find anything that goes into 233. So, 2 doesn't go. 3 doesn't go, because if you add up all the digits, so 3 plus 2, if that number was divisible by 3, then this would be divisible by 3. It's not. Let's pause and see if we can find anything. Alright, and I think we're good. I don't think we have anything that goes into 233. So, let's go ahead and box it up. So usually what I'll do is I'll try 2 and 3, and then I go to some of those weird ones like 7 and 13 and 19 and stuff like that. So if it's a big number, we're not necessarily expecting you to be able to go through and do the prime factorization that is, but we should be able to do it if it's divisible by 2 or divisible by 3, and at least check those. Alright, so moving on to the next one. Always identify the hypotenuse. Find your right angle. Here it is. Go directly across from your right angle. Here's your hypotenuse, or your C. And then the other two are interchangeable again. So I'm going to go A and B. My my formula says c squared equals a squared plus b squared. Whoops. Kind of ran into my c there. Let's move this one over. We'll put c up here. All right. Now we'll plug it in. So c squared, that's 30 squared, equals a squared, which is x squared, plus 25 squared. Now if you need the calculator to know what 30 squared is, that's fine. But I know what it is. So 30 squared is 900 equals x squared plus, and then 25 squared is 625. All right. Now we're just going to solve with a normal equation. So I'm going to go through and subtract 625. Subtract 625. In subtracting 625, I should get, so 900 minus 625 is 275. And that equals x squared. Now I'm going to go through it and I'm going to do the same exact thing. So I'm going to square root. Now I just need to factor tree 275. So I can try to fit it here. So 275. So 275 definitely divides by 5. And if I divide 5, I get, if I divide by 5, I should get, let me try. All right, I get 5 and 55. And then I do 5, or 55 turns into 5 and 11. And if you recall, we're looking for pairs. So I have a pair of 5. When you find a pair, all you do is circle them and write down whatever number you just got done circling. So these are a pair of 5. So 5 comes out, just one of them. And then whatever did not get circled stays inside your radical. So 5 square root 11. That equals x. Okay? Now we're going to go through and do the next one. So the one thing that I need you to notice is I'm going to highlight it. And we have right here our right triangle. You have a right angle right here. Okay? So one thing we need to know is that we can take 22 and we need to go through and split it directly in half. Okay? Technically you should have markings there. So we'll just go ahead and assume, even though we're not supposed to do that, that it's divisible or divided evenly. So this is 11 and this one is 11. All right? So I'm going to go ahead and pause and solve it. So what I have here is that 24 is our hypotenuse. So we do 24 squared equals 11 squared plus x squared. And then we go through and we solve it. So I ended up with the square root of 455. And if you look at my factorization here, it looks like it goes to 5, 13, and 7. None of those are pairs. So our final answer is x equals the square root of 455. All right. Now let's move on to the next question. So the next question is we kind of need to draw a picture. So it says a roofer leaned a 16-foot ladder against a house. So I'll try my best. Here's a house. Great work, Miss Bean. Beautiful. Great. Okay, we'll have 2. All right, wonderful. So it says it leans a 16-foot ladder against the house. So here's my ladder. All right, it says that that's 16. All right. It also says that the ladder is 5 feet from the house. So 5 feet from would go right here. All right. 5 feet from. All right. And then what it's asking us is if you look right here, it says how high up the house does the ladder reach? So that's asking for a vertical height. It says how high, high meaning height as in vertical. So how high? Now, you should know that the house and the ground, one is vertical and one is horizontal, and they should be perfectly vertical and horizontal. So we're going to assume that that makes a right angle, because your house should be perfectly straight up and your ground should be perfectly flat. So now we just need to find which one is the hypotenuse. So I'm going to travel straight across from my right angle. That's right here at 16. That's C. And the other two can be A and B interchangeably. Go ahead and set up the equation. I'll pause it. Hopefully you got this. Now we'll go through and we'll put in our calculator. 16 squared is 256. X squared plus 5 squared is 25. Now we're going to subtract 25 on both sides. Subtracting 25 should get me 231. 231 equals x squared. And I'm going to go through and I'm going to do the square root. Now I'm going to go through and see what I can figure out for 231. So pause. Actually, what I forgot to tell you is since we want the actual distance, so when you're talking about a word problem, if we were in a word problem, you do not need to simplify your radicals. We want to know the exact decimal answers. That's why right below it says decimal answers are only allowed in, and we're going to put word problem. Okay, so we just need to find the decimal for that. So go ahead and pull out your calculator. You can even use your phone. And our answer should be 15.2. So x equals 15.2, and it's feet. 15.2 feet. We'll just go to the 10th. All right. Okay. So the next one says Ashley jogged 3.4 miles east. So can anybody tell me which way is east? Is it up, down, left, or right? East is to the right. So if this is Ashley, she goes 3.4 east. So this is 3.4. And then she goes 5.7 miles south. So south is going down. And it says 5.7. And it wants to know how far away is Ashley from her starting point. That's right here. So right here is the right angle. And we're going to find out how far that Ashley was. So we need to set up our equation. So our hypotenuse is directly across from the right angle right here. And then the two values we're given are A and B. So we have C squared equals A squared plus B squared. Now go ahead and set it up. So C squared, because we don't have that, is equal to A squared, so 3.4 squared plus 5.7 squared. So C squared equals, so I don't know if I'm going to have to pause for a second. I'm going to square them and then add them up. Alright, when this happens to you, you have C squared equals 44.05. That's when I added those two. I'm going to go through and square root. When you get a square root of a decimal number, no matter what, you have to write down what it is. Oh, sorry. So put in your calculator the square root of 44.05. So here's my calculator, and I'm going to do the square root. Looks like 6.6. C equals 6.6 miles. Alright, so pause if you still need to write that down. So we're going to move on to classifying triangles. You can actually use the Pythagorean theorem to classify triangles. Before we could go through and talk about whether they even existed, but now we're going to talk about what kind they are. So what we have here is if C squared is equal to A squared plus B squared. So if they're equal, like we were just doing, then the triangle is right. It is a right triangle. Okay, so if it's equal, we get a right triangle. If your C squared is bigger, so C squared is greater than A squared plus B squared, If your hypotenuse squared is bigger, then the triangle is obtuse. If it is smaller, so if your hypotenuse squared is smaller, then the triangle is acute. Always keep the c-squared on the left side to avoid confusion. So always look at the c-squared. If it's greater than the other side, it's obtuse. If it's less than the other side, then it's acute. And just remember that c-squared, or your hypotenuse, is always, always, always the biggest number. Always. Okay? So here, we need to pick the biggest number, and that's going to be the hypotenuse. That's 9. And it's going to go alone. So, c-squared, I'm going to put a box here because we don't know if it's greater than, less than, or equal to. So c-squared is something to a squared plus b squared. Now I'm going to plug them in. C-squared, so that's 9 squared, is something to 3 squared plus 7 squared. So 81 is something to 9 plus 49. So we have 81 is, let's fill in that box. So we had the box. 9 plus 49 is 58. So that means 81 is bigger, which means that our hypotenuse was bigger, which means that this is obtuse. Okay? Now we're going to do the same exact thing in the next one. Locate the biggest one. Here we go, 29. It goes alone. So I'm going to write, I'm just going to plug it in from right here. So 29 squared is something to 20 squared plus 21 squared. Okay? 29 squared is, I'm not really sure, so let's do the other side. So 20 squared is 400. And then 21 squared is 441. And actually, 29 squared is 841. So 841. Now we'll add it. So add those two, and it's actually equal to 841. So these are equal to each other. When they're equal, this is a right triangle. Always be careful and make sure that they actually make a triangle in the first place, though. So, in case you forgot, that means adding the two small to make sure they're bigger than the big. So 6 plus 11 must be bigger than the biggest, which is 12. 6 plus 11 is 17, so it's definitely bigger than 12. So we will make a triangle, so let's go ahead and do c squared. So c is the biggest. 12 squared, something to 6 squared plus 11 squared. 12 squared is 144. Box there, 36 plus 121. 144 is, so we have 157. So, in this one, the hypotenuse is smaller. So if it is smaller, then this is acute. Okay? And that's about it for classifying triangles. So I did put a little hint there to make sure that you check to make sure it makes a triangle. Okay? And that's all we have. See you in class.